Hello people, so let's solve Trionic Array II question today in Leetcode. So what is it mentioning? Initially, let's understand what a Trionic subarray is. So a array is called Trionic subarray if there exist two indexes P and Q. In a given array, if there exists two indexes P and Q which are not equal, such that from the start of the array to index P it is strictly increasing, and then the subarray with between indexes P and Q is strictly decreasing, and the rest of the subarray is strictly increasing. So that is called a trionic array. You can refer to the question which I have solved earlier. I will put it here somewhere in the I tab. You can access it from there for seeing Trionic Array 1. So this is an advanced version of the Trionic Array 1. Here what they want us to find is to find for all the Trionic arrays which are present in the given array. Okay, and then they want us to find the maximum sum possible for these trionic subarrays. Okay, so let's see the example which they have given. So this is the example: 0 minus 2 minus 1 minus 3 0 2 minus 1. This is the subarray given array. So inside this we need to find an array which is increasing, then decreasing, and then again increasing. This is the type of subarray we are trying to find. So let's see. We start at index 0 and we go here. 0 minus 2. No, it is not increasing, it is decreasing. So we can't take index 0. Let's start from index 1. From minus 1 to minus 2 to minus 1. It's increasing subarray, fine. And then from minus 1 to minus 3, it is decreasing. Nice, very good. So from minus 3 to 0 it is increasing, and 0 to 2 it is increasing. So this is one trionic subarray we got. So what is the sum of this? Minus 2 plus minus 1 plus minus 3 plus 0 plus 2. So we have minus 4 as the sum. So what if the array was like minus 5 minus 4 minus 2 minus 1 minus 3 minus 2 0 3 5 1 minus 1. So if the array was like this, so from here minus 5 minus 4 minus 2 minus 1 till here we have an increasing subarray. From minus 1 to minus 3, here we have decreasing subarray, and again from minus 3 we have an increasing subarray till 5. But there is a catch here. What's the catch? If to find the sum, maximum sum, to find the maximum sum possible, what we need to do? Include minimum negative values, or in other words, I can say use maximum sum possible in left increasing subarray and right increasing subarray, and for the decreasing subarray we can't do anything. We need to include all the elements of the decreasing subarray because that's how it forms. L to P we have a chance to pick, and Q to R we have a chance to pick till where we want to put R, but in this between we need to include all these. We need to include all these elements. So we can decide till where we can consider the elements of our increasing subarray in the left to get maximum sum, and similarly on the right side till where we need to go to get the maximum sum possible, and then we can simply do left plus mid plus right. With this we will get the total maximum sum possible for our given range L comma R. For L comma R we get the maximum sum, and this we need to iterate for the whole given array. For whole array iterate L and R. Very simple question, very simple. So for this, let's put this start writing the code for this one. So if we see, as we got an approach, we are thinking to take a left pointer L, which will be starting from 0 to traverse in the array, and I'll take a variable n which will be having the length of the array, and it was mentioned the answer will be of long, so let's take long ins equal to, there is a catch here, the maximum sum need to be found, so the thumb rule is always initialize with the minimum possible value. So I am going to take long dot min underscore value. This is the minimum possible value for long data type. Fine. So now let's start iterating. While I less than n, L less than n, what we are going to do, we are going to take right pointer which will be L plus 1. So with these two we will be comparing each other. With the right pointer, our main motto is to find the increasing subarray, and then find decreasing subarray, and then find increasing subarray. And we do need to maximize left side sum and right side sum. Okay, so how do we find if the subarray is increasing or decreasing? How can we do it? So in a given subarray, if we compare two adjacent elements, here -5, -4, so if I compare my current element with the one which is just before it, so for nums of r and nums of r minus 1. If this is greater, so then it is increasing subarray, and similarly for decreasing, nums of r to be less than nums of r minus 1. This is decreasing subarray. So to find p, keep checking increasing condition. Keep checking increasing condition. Just keep checking it, and the moment it fails, when this condition fails, then we get our pth index, which is just before it, like here from -1 to -3 the condition fails because 0 1 2 3 4 nums of 4 is less than nums of 3. So for r equal to 4 the condition fails, and the p will be equal to 3, which is r minus 1. P is equal to r minus 1. We get that. And similarly, to find q, we keep checking decreasing condition. And the moment it fails, then we get q, which is just before our current index. So here if you see, from here to here at this index the condition fails, as -1 is less than 5. So here our condition fails here, -2, because -2 is greater than -3. -2 is greater than -3. So our q becomes, here r equal to 5, so q becomes 4, which is just before our r. So q equal to r minus 1. And as we are trying to maximize our sum, but we have a condition L less than P less than Q less than R, which means there should be at least one element included in array less than P and greater than Q, meaning in the sum which we are going to calculate, we need to include nums of P minus 1 and nums of Q plus 1. We need to include these both, because only then the array becomes trionic array. And later we can do the maximization stuff of maximum left and maximum right. That we can get from P minus 2 to L, and here what we can do is Q plus 2 to maximum N minus 1. This is our concept. Understood? So let's try implementing it here. So first let's write for the increasing case. While always check for the index to be within the bounds of the length of array, and then nums of r to be greater than nums of r minus 1, which will be increasing array. So we got our increasing array. Then when will this thing, what are we going to check here? P should be greater than L. So if int P is equal to r minus 1, as discussed, the element which is just before the failure, which is just before the index where we have a failure, is rp. So here if p is equal to our left, then we need to move away. So L will increase. Let's just move forward. We don't want to check anything else. We are just going to move forward. Next, for the decreasing subarray. For the decreasing subarray, again we are going to do the same thing. While r is less than n and nums of r should be less than nums of r minus 1. Then what we are going to do? We are going to increase. I put an extra plus here. So here I will get the q, which is q equal to r minus 1. And what is the condition for q? Q should be greater than p and less than r. So if q equal to p or q equal to n minus 1, or q can't be minus 1 because we need to exclude the last element, which should be increasing, or else no. So that is a failure case. And other one we can say is the next element which is nums of r plus 1 is equal to nums of r. If the next element we are going to get is equal to, then it is not going to be an increasing, it's not a strictly increasing subarray. So that will also fail the condition. So for that as well we need to stop, we should not be checking. But here as we are increasing 1, as we are checking for r plus 1, so let's make sure it is not going index out of the bound, r is less than n minus 1. So this makes sure this condition is not going to give us index out of bound exception. But if either of these three are satisfied, so then what we need to do? We need to move our left pointer to q, to the point where we got the breaking. So from here again we will be able to get the next increasing and decreasing, next trionic array. We will be able to get it from here. So we are going to do this and then continue, because we don't need to check anything extra. We are just going to move forward. And we need to get the sum. So I'll put long result is equal to 0. I'll initialize it to 0. And as discussed, once we get the p, we need to include nums of p minus 1 and nums of p. We need to include nums of p minus 1 and nums of p to get the increasing part, the minimum possible increasing part. later we can think of the expanding towards left, and inside our decreasing part we need to add every element. We can't compromise on this. We can't compromise. We need to include them. Only then we will be able to go for the increasing part. Decreasing part should be included in our sum, so we are including it. Once this is also done, then what will we be doing? We need to check for the increasing subarray on the right side, and as well we need to maximize the sum. So let's take max sum equal to 0 and sum equal to 0 to find the sum and the maximum sum we are getting on one side. And there is one more thing we need to do, is we need to add the one element. Add one element q plus 1 to our array, to our sum which we are having now, because even on the right side we need to include at least one element. And then let's make our right pointer to be q plus 2. We have discussed, right? So for q plus 2 to n minus 1 we are going to go on the right side, and p minus 2 to l on the left side. So that is what we are going to do now. We have r equal to q plus 2, and here while r is less than n and nums of r is greater than nums of r minus 1, which is our increasing condition. So then we are going to take sum plus equal to nums of r, and for the maximum sum we will be just comparing it with the previous maximum sum and store it in our maximum sum. And we need to increase our right pointer, don't forget it. So with this thing we got the maximum sum possible in our right subarray. So we are going to add it to our sum. Similarly, to maximize our left side sum, again we are going to do the same. Max sum is equal to 0, sum equal to 0. Sum equal to 0, and then while we can just put a for loop, that would be better. Int k equal to p minus 2 and k is greater than or equal to l k minus minus. For this part, this is already an increasing array, we know it. That's the reason we have gone till here. We are confirmed that it is a increasing subarray. So we are just going to find the sum possible, nums of k, and similarly we are going to find the maximum sum. Math.max of max sum comma sum. Again we will add it to our result, and at the end we compare it with our already found answer to find the maximum possible. Done. Let's return it. Return ans. So see with the logic, we have our left pointer starting from 0, and we have the length stored in a variable n, and we are taking the answer to be the minimum possible value, to because later we'll be comparing it with the sum which we are getting and take the maximum one. So we are initializing it with the minimum possible value. So for length, if the index is in the bounds of our length of array, only then we will be able to iterate. So we put the condition and we initialized our current sum to be 0, and our right pointer is the index which is just after our left. So we are going to find the increasing subarray limit, and we take the p, the first pivot, and check if it is equal to our left pointer. If it is equal, then this is no longer going to be an increasing one, because the first element itself we have got the pivot, which means it is not satisfying our condition L less than p. So we are increasing and going forward. We are not going to check anything, and we are going forward. And if the condition has satisfied, so then we will be including our pivot index p and the element just before it, both, because we need one element at least one, like -2, -1. Only with that it is forming a increasing subarray. So this has been included here, and then we go on to find our q index, the decreasing subarray. So till the condition is satisfying, once we find an increase value greater, then again we get our q index, our q pivot is found, and the condition for the q, it should be less than r and greater than p. So we put it, if q is equal to p, it is going to fail, and even if it is equal to the end element, if it is equal to the last index, there is no more index elements present to form increasing subarray. So even in that case it fails. So for that also we put, and later we are checking if the element just after our pivot index is equal to our index, our element. If that's the case, even then we will not be able to find an increasing subarray. So for that too we have marked it. For all these cases, we are going to move our left pointer to q. Why q? Because if we move to q, only then the next increasing array will be coming. Before q, we have a increasing and then decreasing subarray. So after q, we can there is a chance to find an increasing subarray. So we have moved the left pointer to q, and we included the element which is just after our pivot to include our increasing right subarray. Increasing right subarray should be present. Include, like here in this example, we are including 0 into our sum, because after this, whatever you want to include or not, it depends on if you are getting the maximum sum or not. We can maximize it, but we need to include 0. Only then we will have satisfied this condition as well. So for that, as we have included q plus 1, we are taking the pointer to be q plus 2, and from there we are checking for the maximum possible sum on the right side. So once we got the maximum possible sum on right side, we add it to our sum, and similarly we are finding the maximum possible sum on the left side, and then we are taking it. So once all these things are done, our left pointer need to be moved to q, similar to what we have discussed earlier. Here also we are doing the same. From q, there is a possibility to get a increasing subarray again. Before that, no, nothing. We can't get a trionic array because we have already checked it. So this is how we are thinking. So let's submit. Oops, we missed a semicolon. Did we miss anything? Okay, we are putting it to be result. Yeah, our test cases are passing. So let's submit. So what did go wrong? What has gone wrong? It is increasing and then a decreasing, but this can't be included. So gone. Later, increasing, decreasing and increasing. This is what we need to take. Decreasing, increasing, decreasing. So if we check for q plus 1, as the condition has got failed, so we check for this. We should not be including it, because if we put q, again this condition will be included. So where are we going wrong? So we are doing the increasing, we are checking for it. We have added our p minus 1 and p, and then we are checking for q to be equal to, if it is so, then we are doing it. We need to check it for n. If r is less than n, only then we are going to check for our q is equal to r. If these both are equal, even then we should not be doing it. That is what we are trying to achieve, right? And then we go we iterate from q plus 2, and then we iterate for p minus 2 to l. This is looking correct. Fine. So it got submitted. Thank you for watching. Do like, share and subscribe.